Okay, so to the recap for Space Invaders. First new thing we learned about was arrays. So you can't, it's not possible to change the size of an array once it's been created. You can create a new array which is a different size, but that can be cumbersome because usually you want to maintain the contents of the array in this case, and you can't do that. You would have to copy all the stuff from the array into a new array, which is possible, but it's a bit of a pain in the backside. If our aliens were in an array, we could move the aliens off screen when they're killed, but the trouble with that is, as our aliens are moving left and right, they're checking if one of them hits the edge of the screen. And if any of them are already way off the edge of the screen because they've been killed, that could mess with the algorithm. Another way to do it, a better way to do it, is to give every sprite a boolean flag, which indicates whether it's active or not. So a boolean active equals true. Set it to false when it's been killed. And that's suitable, but it does result in a whole bunch of useless objects in memory because they've been destroyed. Not a problem in a game like this. It's, you're not going to suffer your frame rate in a Space Invaders game because of having a few dead Space Invaders lingering in memory, but it's a bad habit to get into for future projects. Also, it does mean that every time you do a collision check, you need to check for that active flag first, and same for when you draw them and stuff like that. So it's viable, definitely, but that's why I chose not to go with arrays. You could make the aliens as a two-dimensional array. That's the one with the comma in the middle, and you say how many aliens there are along the x-axis of that array and the y-axis of the array. That's not pixels, that's not necessarily even screen coordinates, although in this case it is. But it's just 10 times 6 aliens, 10 lots of 6 aliens, that's all that really means. And to do that, you could have two different for loops again, create the Space Invaders as normal, but instead of just adding it to the list, you would place it in the x and y position in the array, not the pixel coordinates. Place that new invader in one slot in the array. But that doesn't really fix the problems. It does neatly indicate which place an alien's in, row and column, which would make it a lot easier to launch a projectile from the alien. Just pick a column and go down the y dimension until you find one that's alive at the bottom. But you still need to keep track of which aliens are active. So what about this? Well, you could try a thing called a jagged array. An array of arrays, really. So you've got an array, and each array is made up of other arrays, and each of those other arrays, sub-arrays, could be different sizes. So some of them poke out, so that's why it's jagged. It's a jagged array because some of them poke out further than others, or can poke out further than others. In our case, it probably wouldn't. There are 4 arrays, each array being 10 in size. This kind of system does have its uses, but this isn't a particularly good example of when to use a jagged array because it doesn't really solve any problems. You still need to recreate the arrays every time you remove an alien, or move them off screen, or put in a boolean. It doesn't solve any of that. So, which takes us to lists. And a list is just one type of advanced data structure. There's also decks and queues and all kinds of other things. But a list has an add method. So the add method inserts new items on the end of the list. And there's also multiple ways to remove items from the list. It's actually really just an array, but it's an array that automatically reorganizes itself every time something's added or removed. So it's got a capacity. Let's say you make a list and you put 5 things in it, the capacity might be, say, 10. So it's actually an array of 10, but only 5 of them are available. So if you add something to that list, it becomes 6 out of the 10 used, 7 out of 10, 8 out of 10, 9 out of 10, 10 out of 10. When you try and add number 11, then it has to create a new array, move everything into the new array, which is a bigger array, with a capacity of say 20, and then get rid of the old one. But it does all that for you, which is the good part. So you don't actually have to do any of that reorganizing. You just say add or remove. Lists also use generics. That's the name for this thing inside the angle brackets. You have used that already when loading content, but it just specifies a type that the object or method is going to operate on. In this case, what we're making a list of. We're making a list of sprites. We still need to generate that list, so we use the constructor for a new list. And that does create a list object, so it's a constructor method. It needs round brackets. Every time you try and add an object to a list, you must add an object of a type compatible with this generic. So we could add you must add sprites in this case. We couldn't add integers or vectors or anything like that to our list of aliens. It has to be a sprite. But if we made a subclass, so we made a boss alien, which is a type of sprite, and you made a top alien, which is a type of sprite, and a bottom row alien, which is a type of sprite, they're all types of sprite. So you could add new objects of those classes into the same list and it would still work. But that's a bit more advanced, that's probably for another day. So in a bit more detail, how to add to a list. You use add method, and inside the brackets, the object you're adding. You could add a whole new sprite, or you could add a sprite that we created earlier, because it's a list of sprites. If it was a list of vectors, you could add a new vector, or a vector you created earlier, whatever it is. You can pass in reference that way. You can insert them in specific locations. We don't need to worry about that just now, but just to show you how to do it, instead of doing add, you just say insert a new sprite, or a new invader, or whatever you've got, but tell it where to insert it, and it will push, in this case, it will push number 6 and 7 and 8 along to become, it'll push 5, 6 and 7 along to become 6, 7 and 8. If you need to put it in a specific location, which isn't always necessary. You can remove from lists, and there's a few ways to do that. The remove at method, you give it a number, so you could say aliens.remove at 0, that's the first alien in the list getting removed. If you do aliens.remove at 1, it becomes the second alien you're removing. Aliens.remove at 2, that's the third alien you're removing, and so on. If you count however many aliens there are, let's say there's 50 aliens, there is no alien number 50. It goes from 0 to 49, so you must remember to subtract 1 if you want to remove the last alien from the list. You can also just do a thing called remove, but to do that, the remove method must be given a parameter, which is a reference to an object in the list. So if you're iterating through all the aliens, you can make a copy of each alien individually, and then that gives you a reference to one you can remove. And that's probably the most common way to use the remove method. I don't tend to recommend that. I'm sure some people will, but I don't like using that method much if I can avoid it. And here's why. If you remove from a list as you're looping through it, iterating through it, it breaks the iterator. The S is the iterator, and if you remove S from an array or a list or whatever, from a list or a deck or whatever you've got, then the iterator can't figure out where it left off because that S is gone now. So it can't move from there to the next one. And you get an invalid operation exception. The collection was modified. The collection called aliens was modified, so you can't enumerate through them anymore. You can solve that using a break command that breaks the loop, but that means the rest of your objects don't get iterated through. Probably fine in a real-time game, because who's going to notice a 1 frame delay before the next collision is detected? But it is kind of sloppy, it's a bad habit. And there will be some times when you can't get away with that. There's a bunch of ways around it. You can maintain a list of objects to be removed. So as you're looping through, you can say whether to remove each one or not, and if you do, add it to this kill list. And then once you're finished, you go through the kill list and remove them from the original list. Or you can create a copy of the list and loop through one list while removing from the other list. So like this, for instance, you can take the alien list, turn it into an array, and then loop through the array instead of the list, and then just remove, because it's a reference to the same object. You could remove that object from the list instead of from the array. You can also use predicates. We're starting to get into pretty advanced stuff here. A predicate, like this one here, you can say remove all aliens elements. I'll come back to what that means in a minute, but you can remove everything where y is greater than 300. This is the predicate part. It basically means remove all elements where the element has a position y greater than 300, a y coordinate greater than 300. So what actually is a predicate? It's technically what we call a delegate function. A delegate function is a function where it delegates the code to somewhere else. It could be a method somewhere else in the code that it runs when you call up this delegate. Although in this case, the code is right there in line. Not all delegates are like that. Sometimes there's a separate method, but in this case, it's an inline delegate, which makes it anonymous. Which means there's no name for this method, so you can't call it from anywhere else. And finally, predicates specifically must return a Boolean value, so it can be used to decide things like, in this example, whether to remove an object or not. Let's go back a step. essentially, what we're saying there is, take the element, do this comparison. Does it have a y coordinate greater than 300? And if the answer is yes, if that's a true comparison, then element does get removed. So our predicate is this part here, which gives us a true or false. True, we remove it. False, we don't. But as I say, that's kind of advanced. Don't worry if you don't understand that yet. The other main thing we got was pseudo-random numbers. Computers can't actually make genuinely random numbers, at least not normally, not your average laptop or desktop computer. So instead they use very, very complex mathematical formulas which generates a sequence of numbers, one after another, which are unpredictable to humans. Even to computers, it's very hard to sort of predict the random numbers that are going to be generated. You'll have to figure out the algorithm first. But for all intents and purposes, for most uses, they give the appearance of being random. But to do that, they need to have a number to start from called the seed. Usually we get this seed from the system clock in milliseconds or even ticks. But the trouble with that is in XNA and monogame, the clock has a game time, and that's stored from one frame to the next, and it doesn't change until the next frame comes along. So if you do create two RNGs and seed them at the same time, seed them in the same frame, they'll have the same seed number and will follow the same random pattern, which might be a bit counterintuitive. It's best to avoid multiple RNGs for that reason. If you have to do it, make sure that either it doesn't matter if they follow the same sequence, or that you seed them with different seed numbers somehow. So the random class is what we use to actually do this. We create a random object, I've called it RNG, and that bit there, when you construct it, actually seeds it using the clock. And you can pick the next random number like this, RNG.next. If you say two numbers inside the brackets, it will give you a random number between 0 and 100, or between 10 and 1000, or whatever two numbers you put in. The second number is exclusive. If you just put one number in there, it goes from 0 to that number. And if you don't put any numbers in there, if you just do open bracket, close bracket, it just gives you a random integer. Sometimes useful, but not too often. A couple of last bits and pieces. There's a thing you can do called preloading, which simply means loading content before you need to use it. What you don't want is to load in large content during gameplay, because it causes lag. You know, if you're loading a 3D model or a map or whatever during gameplay. The content manager is what we use to do that in monogame. So the content manager loads in stuff from disk, stores it in memory, and keeps a reference to it. It must keep a reference to it so that the garbage collector never deletes it. Also, if you need to load the same thing again, let's say for example with our shields, we loaded the same image 3 times. But what actually happened was Content Manager, the first time it was told to load the shield, it said, okay, I need to go away and load this from disk. Second time we asked for that image, it said, well, hang on, I've already loaded that. Here's a reference to the same texture. It gives you a pre-loaded copy. But you can also store references of your own to explicitly handle this, kind of like I did with the Spawn Alien Wave. Which leads me to the final thing, the garbage collector. One of the reasons why C# is slightly slower than C++, which is a factor, I guess, in AAA games development. The garbage collector, or GC for short, it keeps track of all the memory that's allocated to any object you create. So you create a texture, and it keeps track of all the memory that texture takes up, for example. But it also keeps track of all references to that object. And so that's so that it knows if all of those references are removed, then it's safe. GC knows it's safe to remove that object from memory. If you don't do that, you could end up with a memory leak. And that's why the GC stops memory leaks. But it does incur a bit of processing overhead by keeping track of those things. But it means the programmer does not need to explicitly do that yourself. Which makes C#. It's one of the reasons why C# is significantly easier to learn than C++, in my opinion. But since Content Manager maintains references to items that's loaded, the GC will not ever delete them until the Content Manager itself is destroyed, and by that point your game is probably closing down anyway. So that's preloading, lists, and random numbers. That's all for now. Thanks.